Hey, what's up, my dear students? It's Naresh Babu. Welcome back to Physics Crash. Students, in this session, I'm going to discuss about JEE 2023 MCQs from current electricity. Let us start the game. Current electricity. JEE 2023 MCQs. Here the first question. As shown in the figure, so here one figure is given, okay. A network of resistors is connected to a battery of 24 volt with an internal resistance of 3 ohm. So here these all resistors connected to a cell of 24 volt having internal resistance 3 ohm. The currents through the resistors R4 and R5 are I4 and I5. So here the current through these resistors R4 and R5 are I4 and I5. The values of I4 and I5 are, so we have to find that I4 and I5. Here are the options. Option 1, I4 is equal to 8 by 5 ampere and I5 is equal to 2 by 5 ampere. Option 2, I4 is equal to 24 by 5 ampere and I5 is equal to 6 by 5 ampere. Option 3, I4 is equal to 6 by 5 ampere and I5 is equal to 24 by 5 ampere. Option 4, I4 is equal to 2 by 5 ampere and I5 is equal to 8 by 5 ampere. Solution. From circuit, total resistance we will calculate. That is, total resistance is equal to 3 plus 1 plus 2 plus 4 plus 2, that is equal to 12 ohm. How we got this? Look at here. See, cell internal resistance 3 ohm. So 3 and R1, R2 connect in parallel. Their equivalent resistance R by 2, that is 2 by 2, 1. So we got 1 here. Next to R3, 2 ohm. Next R4 and R5 are connecting parallel. Their equivalent resistance is 4 and R6 is 2 ohm. So we got 12 ohm. Total current. See, from Ohm's law, we can write I is equal to V by R. Now substitute in the place of V 24 volt and total resistance 12 ohm. So we got 2 ampere. Now from circuit, we will calculate potential difference across R4 and R5, that is V4 is equal to I into total resistance of R4 and R5, that is R4 R5 by R4 plus R5, that is equal to I, we got 2 ampere. The equivalent resistance of R4 and R5 is 4, so 2 into 4, 8 volt. Now we will calculate I4, that is current through R4, that is V4 by R4. So V4 we got 8 volt by R4 20 ohm. So 8 by 20, if you divide with 4 table, you will get 2 by 5 ampere. So we got 2 by 5 ampere. If you subtract I4 from this total current, that is 2 ampere, then we will get I5, that is 2 minus 2 by 5, that is equal to 8 by 5 ampere. So we got I4 is equal to 2 by 5 ampere and I5 is equal to 8 by 5 ampere. From the given options, option 4 is the answer, my dear. Now we will go with second question. Here the second question. The charge flowing in a conductor changes with time as Q of t is equal to alpha t plus beta t square plus gamma t cube. That means here charge given as a function of time. That means if time changes, Q changes. where alpha comma beta and gamma are constants. Minimum value of current is, so we have to calculate minimum value of current. From the options, option A alpha minus 3 beta square by gamma, option B alpha minus gamma square by 3 beta, option C beta minus alpha square by 3 gamma, and option D alpha minus beta square by 3 gamma. Solution. See, we know I is equal to derivative of q with respect to time. So if you do derivation for q with respect to t, derivative of alpha t alpha, derivative of t square here 2t, so we will get minus 2 beta t, derivative of t cube 3t square into gamma, so we will get 3 gamma t square. For minimum current, di by dt should be 0. That means to get minimum value of current, derivative of I with respect to time should be equal to 0. So now we will do derivative for above equation with respect to time. So if you do derivative with respect to time, that means derivative of I with respect to time. So here derivative of alpha 0, okay. Derivative of minus 2 beta t, that is minus 2 beta, and derivative of 3 gamma t square, we will get 6 gamma t. So we got 6 gamma t minus 2 beta is equal to 0. That implies, now divide with 2 on both sides above equation, we will get 3 gamma t minus beta is equal to 0. That implies, see, from the above equation we will find t. So we will get t is equal to beta by 3 gamma. Now we will substitute the value of this time in the first equation, then we will get I minimum. That is, I minimum is equal to alpha minus 2 beta. In the place of t, we will substitute beta by 3 gamma plus 3 gamma t square. In the place of t, we will substitute beta by 3 gamma whole square. Okay. That is equal to alpha minus, here 2 beta into beta by 3 gamma means we will get 2 beta square by 3 gamma plus 3 gamma into beta by 3 gamma whole square means we will get beta square by 3 gamma. Now in the above equation, if we write beta square by 3 gamma commonly outside, inside we will get 2 minus 1. That means inside the bracket we will get 2 minus 1. So finally we got alpha minus beta square by 3 gamma bracket of 2 minus 1. So 2 minus 1 means 1. So we will get alpha minus beta square by 3 gamma. So we got I minimum, that is minimum value of current, is alpha minus beta square by 3 gamma. From the given options, option D is the answer, my dear. Now we will go with third question. Here the third question. If a copper wire is stretched to increase its length by 20%, the percentage increase in resistance of the wire is dash percentage. Solution. See, I will consider that L1 is equal to 100 meter. So length increased by 20%. So L2 will be 100 plus 20. That is 120 meter. In stretched case, we know that R directly proportional to L square. Why? Because here volume is constant. So we will get R directly proportional to L square. So from this, we can write R1 by R2 is equal to L1 by L2 whole square. That is equal to L1 plus substitute 100 by L2 plus substitute 120. 0, 0 cancel. Then 10 square means 100. 12 square means 144. So we will get 100 by 144. That implies, from the above equation we can write R2 is equal to 144 R1 by 100. So that is equal to 1.44 R1. So if you multiply with 100, we will get 144 percentage of R1. Now percentage increase in resistance, that is 144 percentage of R1 minus 100 percentage of R1. That means 144% minus 100%. That is equal to 44%. So the answer is 44%. Now fourth question. The resistance of a wire is 5 ohm. Its new resistance in ohm, if stretched to 5 times of its original length, will be. So here the options: option A 625, option B 5, option C 125, and option D 25. Solution: in stretched case, we know that R directly proportional to L square. So here I will apply shortcut. Here L increased 5 times. So in the place of L, 5 you substitute, then 5 square you will get. So R is equal to 5 square, that is equal to 25. So R is equal to 25. So that implies, see, if R is equal to 25, we can write R2 is equal to 25 times of R1. That is 25 into R1 given 5 ohm. So 25 into 5, that is equal to 125 ohm. So from the given options, option C is the answer, my dear. Now we will go with fifth question. A uniform metallic wire carries a current 2 ampere when 3.4 volt battery is connected across it. The mass of uniform metallic wire is 8.92 into 10 power minus 3 kg. Density is 8.92 into 10 power 3 kg per meter cube. And resistivity is 1.7 into 10 power minus 8 kg ohm meter. The length of wire is. Here the options. Option A L equal to 6.8 meter. Option B L is equal to 10 meter. Option C L is equal to 5 meter. And option D L is equal to 100 meter. Solution: from Ohm's law, we have resistance R is equal to V by I. That is equal to V given 3.4 volt by I given 2 ampere. So that is equal to 1.7 ohm. So we got resistance 1.7 ohm. So from R is equal to rho L by A, we can write R is equal to rho into density into L square by mass. So how we got this? So here multiply numerator and denominator with L. So in the numerator L square we will get. In the denominator A into L volume we will get. In the place of volume we can write mass by density. It's reciprocal, density by mass. That implies, see, from the above equation we can write L is equal to root over Rm by rho into density. That is equal to, if you substitute all the terms in the place of R 1.7, in the place of mass 8.92 into 10 power minus 3, in the place of rho, that is resistivity, 1.7 into 10 power minus 8, in the place of density 8.92 into 10 power 3, then we will get root over 10 square. So root over 10 square means that is equal to 10 meter. So we got the length of the wire is 10 meter. So from the given options, option B is the answer, my dear. That's about this session, my dear students. If you like it, please put a like for my video. Please share it and subscribe it. Thanks for watching my video. Bye, students.